So, this is a setup, experimental setup for measuring surface tension of a liquid by capillary rise method. So, I have discussed about the working formula of this experiment. So, what was the working formula? So, working formula was basically the surface tension is gamma equal to rho g r h plus r by 3 divided by 2. R is the radius of tube and h is the height of the liquid, right. So, in this experiment basically rho is the density of the liquid. So, it is supplied, we do not need to measure, and g is the gravitational acceleration. So, that also known value. So, only r and h that we have to measure from this experiment. So, this is the setup for measuring the surface tension. So, here you can see we are using 3 tubes. We are using 3 tubes of different radius. So, what does it mean? It basically we are doing the experiment for 3 different radius. So, we could do one by one, but in this setup we have arranged in such a way that simultaneously we can do the experiment for different radius, right. So, we will do this experiment for different radius, that is basically here we have taken 3 radius. So, these 3 tubes having different radius, and height of the water depends on the radius. If radius is smaller, height of the water will be higher. Okay. So, and besides there is a needle, you see this end of the needle, it is just touching the surface of the water. Okay. So, we want to measure the height and we want to measure the radius. So, first we will measure the height of the water. Okay. So, what is the height of the water? So, height of the water basically from the surface of the water in the beaker that where we have taken water. So, that water surface that from that water surface, what is the height of the liquid column in the tube. So, that we will measure. So, for measuring this height we are using this instrument. This instrument is basically the travelling microscope, and already I have discussed about this instrument in previous experiment. Again I will tell about this instrument. So, this travelling microscope have basically we can just move this microscope basically in vertical direction as well as in horizontal direction. So, it has 2 scale, one is horizontal scale and another is vertical scale, right. And this both scale, it is basically equivalent to slide calipers. So, it has main scale as well as vernier scale. Okay. And vernier constant of this one has to find out. So, how to find out that you know. So, here basically 49 division, here you can see this there are 50 division in vernier scale. So, that coincides with the 49 division of the main scale. Okay. So, to calculate this vernier constant, we have to know the value of the one small scale division of the main scale, linear scale. So, that is basically here it is 0.5 millimeter. So, your vernier constant will be 0.5 millimeter divide by 50. So, that is that equal to 0.001 yes 0.01 millimeter, and in centimeter it will be 0.001 centimeter. So, least count for this both scale, for this horizontal scale as well as this vertical scale. So, this least count is 0.001 centimeter. So, we have to note down this least count, the basically vernier constant. Now, let us now we have to measure the height of the liquid in the capillary tube. So, I have 3 tube. I have 3 tube of different radius. So, let us see the water column this inside the capillary tube. Yes, I can see you see this height here, this the height of this liquid column in this tube, and here height is higher. So, that means radius of this one is must be smaller. So, here this is the height, okay, and in this case height is this one. So, this the this tube having higher radius. Okay. So, these 3 heights because of 3 different radius. So, we have to measure the height of these columns from the surface of the liquid. So, to using this microscope to get the reading of this surface of the water. So, we have used this needle. At the end of the needle, just it is touching the water surface. Okay. So, from this microscope first we will focus at this end. Okay. Then we will note down this reading on the vertical scale, and then we will move up this microscope and focus at the top end of this liquid column, and then again we will note down the reading on the vertical scale. So, difference between these two reading is basically will be the height of the liquid column. Okay. So, for that I think we can you just focus, and so I think here it is already focused. So, we have to, so in middle, so we have focused it at the at this end. So, if I see, I can see this it is a convex type of end we can see through microscope, because in microscope we get this basically inverted image. So, basically here this this curvature on the top surface of the liquid column is basically this concave type, but in microscope I am seeing it is in convex type. So, this crosswire of this microscope I have set at the just top surface of this convex edge, okay. And then I will take reading. So, it is already set. So, this reading we have to take here. You can see this the 0 of this vernier, this is the 0 of the vernier, and this reading is yes, it's the I can see it's the 11, it's the 11 point something is difficult to see for me, but I think using the yes. So, using the magnifying glass I can take reading. Yes, it is basically 11.0, yes, and slightly it is it is between 11.0 and 11. it's the 11, yes, it's the 11, yes, 11.0 and 11.1, it is in between these two reading. So, now we have to find out uh, the number of divisions, okay, which division of vernier scale coincide with the one line of the main scale. So, that we have to find out, as you know this how to find out. So, this fine. So, this way one has to take basically reading. Okay. So, here it is slightly difficult to just take, but this is the way, as you know this you have to take reading as you take in vernier slide calipers. So, this is the one reading of one. So, for this middle tube. Okay. So, then we can take this same way, we can take this reading for the other one. I can move I think this way. Can you please just set to the next one. Okay. So, we will set to the next one, we will focus to the next one. Okay. Yes. So, we are focusing to the next one. First we just move the travelling microscope horizontally, and then we are adjusting the vertical height. We are adjusting the vertical height to just to focus that I think this we are focusing this one here, we are focusing this one here. Okay. And yes, then we have to yes, we are focusing. Okay. Yes. So, this fine adjustment, fine this height adjustment you can see. So, yeah, through the microscope if I see, yes, it just nicely focused and cross wire coincide with the upper surface of the concave edge of the liquid column. Okay. So, now we will take this same way here as I showed this, we will take the reading. Now, this reading is it looks to me it is 10 point, yes, it is 10 point yes, it is 10.123, it is 10.3. This reading is between 10.3 to 10.35. Okay. So, now from vernier scale one has to, the vernier constant is 0.001. So, we will find out the vernier divisions which coincides with the main scale lines. Okay. So, we will find out the reading for this tube. Okay. So, this way again this other one also we have to take reading. So, these three readings we will get for these three column in three tube. Okay. So, now we will take the reading of this water surface. So, basically we will focus at the end of this needle. So, can you please focus at the end of the needle, this microscope, yes, here. So, we are focusing basically needle okay, using the microscope, travelling microscope, and it takes light, it takes some times to focus it, because you have to move horizontally and then you have to adjust vertical scale. Okay. So, here mainly I am showing you how to use this travelling microscope to focus this liquid. So, in this case we have focused this cross section is at the end of the needle. So, needle end is touching the water. So, this the basically this, now we can take this reading. This reading is basically is around 10 point, I can see 10.1, it is around 10.1, yes, this 11, this is 10.1. So, now you have to take vernier scale reading and find out this what is the reading for this needle end. Okay. So, this the needle end, this is the same for all 3 tubes. Now, to find out the height of this water H, as I showed in working formula. So, this earlier this top of the water surface in the tube, that if we tell this is the H2, and this water surface reading or needle end reading, if it is H1. So, your height of the water will be H2 minus H1. Okay. So, same H1 will be subtracted from this all 3 other readings. So, we will get height for 3 radius. So, that we have to note down. Okay. So, this way we have to measure the height of the liquid column in the capillary tube. Okay. So, this one parameter thus we have measured. Okay. So, I have data, I have taken data. So, I will discuss how to analyze the data and find out the surface tension or calculate the surface tension. So, next we have to measure the radius of the tube. So, I have 3 tubes. So, it has different radius. So, I have to measure the radius of the tube. So, there are 2 methods to measure it. So, one method is just we can put mercury into the mercury into this capillary tube, and then we have to measure the length of the mercury. We have to measure the length of the mercury column. So, I have mercury also, but basically yes, I have mercury. So, this mercury, yes, this is the mercury. Okay. So, this mercury I can put inside this capillary tube. So, using this you see needles, medical needle. So, we use for taking blood from the body. Okay. So, this we can use, but then we will basically measure the length of this mercury, and then we will take weight of the mercury and from there basically if you know the density of the mercury. So, weight of the mass of the mercury will be m equal to rho g h basically. So, mass will be rho g h. Rho g h means here rho g it's it will be mass will be equal to this volume into density. Yes. So, volume into density. So, volume of this Mercury will be area, cross section area, that is pi r square into this height or length of this Mercury column. So, if it is h, so pi r square h, that is the volume, into rho. So, that will be the mass. Okay. So, that mass we will use balance to measure the mass of this one. Okay. So, from there we can basically calculate the radius of this Mercury tube. So, this is one way one can find out the radius of the capillary tube. But here we will use another method. So, that I will explain and show you. So, basically we will use this microscope to measure the radius of the capillary tube. So, from this through this microscope you can see clearly this hole of this tube. So, this cross wire I can put at the one edge of the hole. So, this left side of the hole, left edge of the hole. So, this basically inner side, inner diameter I want to measure, or inner radius I want to measure. So, whatever hole we will see, this cross wire, vertical cross wire I put at the left side, left edge, then we will take this reading, and then I will set this cross wire, vertical this cross wire to the right of the edge. Okay. So, then this is basically I have to take from vertical, so from horizontal scale. So, 2 reading I will get from left and this from right. Okay. So, from this horizontal scale, and if you take difference of these 2 reading, then you will get the diameter of the this capillary tube, that is inner diameter of the capillary tube, of course. So, from there you will get the radius. Okay. So, can you please just so, just to remove the this water beaker, okay, and just turn this tube in 90 degree, okay, in 90 degree. Okay. Now we will focus the hole, we focus this tube. So, we will focus each tube. For each tube I have to measure the diameter, okay, or radius. So, we are focusing now the middle one. Okay. So, in microscope, basically that's why we are using microscope. The smaller things you can see in bigger way. Okay. So, this hole in microscope basically small hole, but you will see very looks like very big one. Very nicely I can see. So, this cross wire now set at the left edge of this hole. Okay. So, now I have to take reading, again I have to take reading from here, from vertical, from this horizontal scale. So, here also horizontal scale, this I have this 0 0, and from here basically you can take this reading. It is a 14 point something. Okay. So, that accurately you have to take this read this reading from vernier constant. So, one can find out this total reading. So, vernier reading as well as this main scale reading. So, total reading for this left edge of this hole, and then I will move towards the other side to just just now vertical crosswire I am setting to the other edge. Okay. Yes, it is now at the other edge. So, now again I have to take reading for this position. Okay. So, difference between these two reading is basically radius of the not radius, it will be diameter of this tube, and half of this diameter is basically the radius of this middle tube. Okay. So, same way one has to measure this one radius of this one and also the radius of the other one. Okay. So, for 3 tubes we will find out the radius using this travelling microscope. So, for this case we are using the linear horizontal scale of this microscope, and for measuring the height you have seen that we have used the vertical scale of the microscope. Okay. So, now we have data. So, we have basically 3 sets of data. So, in working formula this I have shown you this, we have to measure height and radius. Now, experiment generally we repeat all the time, we repeat. So, here we repeated simultaneous measurement we have done. So, here we have varied the this diameter of the tube, and height we cannot vary because it depends on the height depends on the radius of the tube. So, we varied the radius of the tube, and for 3 radius we have measured the height. So, we have 3 sets of data. Now, we will calculate for each sets of data this surface tension, and then we have to take basically average of these 3 datas, then that will be the final result. And I will discuss about the data, how to record the data and how to calculate, and finally, how to calculate the basically this error, percentage error or most probable error for this experiment. That details I will discuss in next class. Thank you for your attention.